calculating a two-proportion z-test statistic by hand and using StatCrunch. So you might have looked at those formulas for the z-test statistic and thought they looked crazy and complicated. So this video is just about how do you calculate it, both by hand and using StatCrunch. So we'll look at an example that we saw in the previous video, and it is this. The Pew Forum on Religion and Public Life has over time conducted surveys to assess American support for stem cell research. In 2002, 43% of Americans expressed support for stem cell research. Later in 2009, 58% supported this research. The researchers from the Pew study interviewed two random samples of people, and a summary of what they found is in this table below. So here's our summary. In other words, in 2002, they interviewed 1,500 people, and they found that 645 of them supported stem cell research. In 2009, they interviewed 1,500 people, and they found that 870 supported stem cell research. So we have this two-way table that you've seen previously, or just this type of table you've seen. Now, we need to know the observed value of the test statistic to test the hypothesis that P1 is not equal to P2. And for this video, we're only just finding the test statistic. We're not doing an entire hypothesis test, but we do need to know some of the stuff related to it. So our null hypothesis in this scenario is P1 equals P2. We saw this in the previous video. Our alternative hypothesis is P1 is not equal to P2. So what is P1? P1 is the proportion of Americans who supported stem cell research in 2009, and P2 is the proportion who supported it in 2002. Okay, now, how do we do the test statistic part of a hypothesis test? We use this formula to calculate our test statistic, and there are all these individual pieces within this formula that we need in order to calculate it, and those are given right here. So take a minute and look at these. Okay, now how do we do this by hand? That's what we'll do first. So what we do is we calculate the individual components, so P1 hat, P2 hat, and the standard error. And so for P1 hat, because population 1 is the people in 2009, so we were told that, we calculate P1 hat by calculating the proportion of people who supported stem cell research in 2009. Now remember, to calculate a proportion, we take the total number of people who have that quality, in this case 870, and we divide by the total number of people that we looked at, so the number of people in our sample. And so that's how we get 870 over 1,500 equals 0.58. Note that we have seen this number, but we didn't see where it came from in the previous video. Now for P2 hat, we do a really similar thing. P2 is population, it's the people in 2002, and we want to know the proportion of those people who supported stem cell research, and that's 645 over 1,500. If we do that, we get 0.43. Now for the standard error, we're going to need the pooled p-value, so we need p hat. Now by definition, p hat is the number of people who supported stem cell research in 2009 plus the number of people who supported it in 2002 divided by the number of people in each of our groups. So N1 plus N2, and then we are looking at the total number of people who had our quality of interest plus the total number of people who had our quality of interest in both of the groups. Now, we haven't seen this one before, so I'm going to flip back to all the formulas. Oh, it might take a minute. Okay, so this is our p hat, and so I'm doing number of successes in sample 1 plus number of successes in sample 2 over N1 plus N2. So that's how I got that. Okay, now that we have p hat, we can calculate our standard error. So the definition of standard error for these problems is we take p hat times 1 minus p hat. So notice I'm using this p hat right here. And then we do parentheses, and if you don't include the parentheses on your calculator, it will not give you the right answer because it won't distribute this stuff in front. And then you do 1 over N1 plus 1 over N2. And then you take the square root of that. So if you do that, you get this number 0.018257. So a bit of work, kind of a pain to do it by hand. Now that you have the standard error, you can go ahead and calculate z. So our test statistic is going to be given by this formula, and what we do is we plug in all the things that we just found into it. So notice I didn't write 0 here. There's no 0 because 0, if you subtract it, it doesn't do anything, so you don't have to write that down. So we do P1 hat, 0.58 minus P2 hat, and then we divide by the standard, we just found the very last thing we found, and we get 8.22. Now this number is our test statistic. It's a number that gives us a sense of how far away P1 and P2 might be. Now, how do we do it with StatCrunch? It's a bit easier with StatCrunch, and so you don't have to worry about making a computational mistake or a calculator error if you do it this way. If you want to do it both ways, you can double check that you get the same numbers or like super close numbers. Now to do it, we go stat, proportion stats to sample with summary, and what's going to happen is a box that looks like this thing on the right will pop up. And it probably looks familiar to some stuff you guys have seen before. Well, it definitely does. And so when you see this box, you're going to have to enter in sample 1 info and sample 2 info, and you're going to make sure that hypothesis test is clicked. And then you're going to make sure that the numbers here and the symbol here are correct. So let's start with the boxes up at the top. So we're going to need to know what to fill in for sample 1 and sample 2. Well, sample 1, we need number of successes. And that's the number of people who support stem cell research in sample 1 are people in 2009. We know that's 870. Now, we also need number of observations, and we know that's 1,500 from the two-way table. For sample 2, that's the people in 2002, number of successes or number of people who supported stem cell research was 645. And number of observations there, 1,500. So that's what we're going to fill into those boxes when we get to StatCrunch. Now, if you look over to the side here, we want the null hypothesis P1 minus P2 to be 0 because our null hypothesis is that P1 and P2 are the same as each other for the type of hypothesis testing we're doing. Now, we want P1 minus P2 to be not equal to 0. That would, if you solve for, if you move P2 to the other side by adding it to both sides of this, you get P1 is not equal to P2. Okay, so we're going to get out of full screen and I'm going to show you how to do this in StatCrunch. So go to stat, proportion stats, to sample with summary. And then we fill in what we just found on the slide. So 870, 1,500, 645, 1,500, and then we make sure hypothesis test is clicked. This is 0 and this is not equal to. Notice I could change it around. We're going to do another video where we actually do the whole hypothesis test and look at this again. And then we push compute. And then this box pops up. Now, right now, for the purposes of this video, we're interested in finding the test statistic. And you can see it right here. It says Z-stat. And there's other stuff here, but we'll do another video where we do a whole hypothesis test. So let's not worry about it right now. Okay, so what happens is we got this box and we found out that our Z statistic was 8.2, and that's the same thing that we got before, so that's great.